So we're going to cover parametric equations. This is going to be an intro to parametric equations. And I actually remember in college when I went over parametric equations, and I thought to myself, root word is parameter. I thought, I'll just look up in the dictionary what the parameter is. And I remember very clearly looking up parameter and getting something really, really unhelpful and vague, like something that varies. And my thoughts were probably something close to, welcome to Facebook, because it really wasn't that helpful. But a parametric equation is going to be something that is based on a parameter. So, for example, here, problem number 6 from the book, we're going to find your x and y coordinates as being a function of t. So t in this case is your parameter. I want to see what happens when we choose different values of t. So let's choose a few simple values in this particular case. And you notice that my t table here is a little bit of the expanded version. So I've got a spot for t, and we'll choose some simple values like 0, 1, 2, and 3. And see what kind of values we get for x and for y. So if we plug those in, 0 for t gives me 2 for x and 3 for y. And then plugging in a 1, I get 5 for x and 5 for y. And so on. And you can keep on plugging these in. Continue on, let's see, plugging in a 2, I get 8 and 7, and then 11, and well, it's going to go up by the slope, so it'll be 2, etc. So it's a different way to generate pairs of points. They're both based on t. Let's take a look at what this is going to look like. And let me see here. Got a Desmos link. I'll try and share that with you. Let's see, that's the wrong one. 10, 1, 10, 1. There we go. All right, so let me just copy this link and I'll put it in the chat for you guys if you want to follow along. There you go. So here's our link. And if you look at the points that we came up with on our sheet, I've got those exact points right here. 2 and 3, 5 and 5, 8 and 7, and then finally 11 and 9. So there's our points. Now what do these points kind of suggest? What do you notice about all these points?
They're linear.
Yeah, they all seem to be in a straight line. So let's go back and see if we can't figure out what that line is by eliminating the parameter. Now the parameter is t, that's what all this varies on. So let's see if we can't get rid of the t and just come up with an equation in terms of y and x. So let's think how we want to do that. What I'll do is I'll take this equation here and solve it for t, and then take that expression and substitute it in here. So that's the game plan. We'll see how that works. So let's see, we get x equals 3t minus 2. So x minus 2 equals 3t. X minus 2 over 3 equals t. And so that's good. We can plug this into here and figure out what y equals. So based on that, y is going to equal 2 times t plus 3. So that's going to be 2 times x minus 2 over 3. You can think of that 2 as being 2 over 1. So I'll just distribute that. And that becomes 2x minus 4 over 3 plus 3. And that's fine. You can leave it like this as far as Desmos is concerned. Something about it, though, cries out to me for a little bit more help. If I divide both terms in the numerator by that term in the denominator, we're good there. And then I need to add 3. But instead of just adding 3, let me think of this as being not 3, but how about 9 over 3? Can anyone suggest a reason I wrote this as 9 over 3 instead of 3?
To add the fractions.
Yeah, perfect. So I can add the fractions. I got a common denominator. And now this is an equivalent equation in just x and y. So we eliminated the parameter. Eliminated the parameter. Okay, then you'll be called upon to do that quite often. Let's take a look at its graph. Does it match up with whatever else we had going? Well, if I click this on, and you can see that I didn't bother to do all the extra work that we just did, which was to get common denominators, but the line does pass through these points that we have. You can graph this parametrically in Desmos this way by just listing the x and y coordinates as being, some function of t. X was 3t plus 2, y was 2t plus 3. I'm not going to quiz you on, your skill in Desmos, all right? That's not what this is about. But you should understand how to do some of this stuff on a graphing calculator. Let me do one other thing here. Suppose instead of 3 for the maximum for t, what if I did 5? Oh, then it goes farther. What if I did -2? Then it goes farther still. So I can make this go as far as I want just based on the values of t that I choose. And of course, if I eliminate the t, then I can just get everything. How's that first one looking so far? Let's learn how to do this on our graphing calculators. So I'm hoping that this is familiar, but if it's not, that's okay. I'm going to go at a pace that I hope that you can keep up with. So take out your TI84 plus or TI83. If you got an 83, it's probably older than you are, but that's okay. They still work good. And you know what? This isn't what we want. Let's hit the mode key. So you hit the mode key, you go down to function, and then to the right one for parametric, and press enter. That puts you in parametric mode. That's exactly what I want. So once again, you hit the mode key, you go down 3 times, which is what this is telling you, to the right once and press enter. Now that we're in parametric mode, now let's go back to y equals, and you should see a difference between the equations we had just a minute ago and what we got now. For instance, what looks different here than what you're used to seeing?
There's like 2 separate things for each graph.
Yeah, so there's 2 separate things for each equation. So this is the first equation. It's going to graph in blue. If I kept things the same, the next equation would graph in red, etc. So let's type in those 2 equations. Now it's going to be 3, and then usually I hit this X key, but something different is going to happen when I hit the X key now. Can you see what's different?
It says T.
Yeah, you got a T, and that's because we're in parametric mode. If you look at the face of this, it says X, T, theta, and N. And I think we'll use all but maybe the last of these in this course. So we've used X a lot. That's your regular function mode. T is your parametric mode. Theta is polar mode. N is sequential mode. Not sure we'll use that much. We can, but I'm not going to force it. This class is about calculus, not necessarily using the graphing calculator. So let's type in both equations, 2t plus 3 for the second of these. So that looks good. But now we got to set up a window. So for my window, let's just kind of be shy for a moment and go 0 to, I don't know, we did 3 earlier. Let's do 3 now. T-step. Now this is a little bit different. We haven't had to deal with something like this before, but T-step says, okay, I'm going to plot a point at 3, and then the next one will be this far away. So let's just make T an even 0.1. We'll describe what that's going to mean later. So what happens is it'll start at T equals 0. It'll figure out the value of X and Y, and it'll plot that point. And then it jumps up to T equals 0.1, figures out X and Y again, and it plots that point. And it keeps on going all the way up to 3. Now, I don't remember the graph perfectly, but I don't think we have to have our Y values set between -500 and 300. Nor do I think I need my X values to be between -6 and 12. But here's the wonderful thing. You don't have to think. Once you have T-min and T-max and T-step set, the T's, press the zoom key, and then 0, zoom fit. And what's nice is that it's going to adjust everything for you from that point. Yay. Now the downside is that, sometimes it does things that we don't really like. For instance, if I look at my window, I can see that it doesn't include the x-axis. So for y min, let me go down to -1. That way it's a little bit below y equals 0, so I can see the x-axis. Now I'll press graph. Okay, that at least somewhat looks like the graph that we had earlier on Desmos. Nice. So how's that one looking? You able to graph that? Okay.
Yeah.
Thank you.
I had a question.
Yeah, please.
So at the beginning, when you started it, you put 3t minus 2. Why did it turn into a
Plus
minus 2?
Plus 2.
Oh, okay. I think you wrote minus though.
Did I write a minus? No,
But
it looks like a plus.
Oh, it worked out anyway. So okay, cool.
Okay. No, I think I got a plus. Maybe I said a minus, and if I did, my bad. And thanks
I
for
think
checking
you
me.
ended up working out in the second one. I don't
Oh,
know.
right
You see what
here.
I'm saying? Yeah, but then under it, it's
Yeah.
well,
So the cool thing is that 2 mistakes cancel each other out. So if you make your mistakes in even pairs, then you'll be great. And obviously, I adhere to that rule because it worked out great. So
okay, awesome.
All right. Anything else? Now, if you have access to whatchamacallit, if you got access to D2L, you can download the handout for this section. I put it online, and it's just nice because it gives you some of the equations and some of the graphs that we're going to need and want to look at. So the next one we're going to work on is this one, and I'll write it down as well. So let's see. Call this example A. Even though we already did an example, you could say arguably that was my example A, but it's my class, so I'm going to call this one example A. E to the negative t plus t, and y is e to the t minus t, or -2 less than or equal to t less than or equal to 2. So same thing on this one. It's just that they want a little bit more from you after you graph this. So this one's not going to be too bad. Let me see. Is it easier if I do things here? Does that help out? You can see all the keystrokes that I use, or doesn't that matter? Are you able to keep up with things?
That helps.
That helps? Okay. All right, I'm going to clear out these keystrokes for the last example. Let me see. Let's clear this one first, and this one second, and then clear out these. Yes. So for the current example, let me just go back here real quick. It's going to be e to the negative t plus t, and then y equals e to the t minus t between -2 and t. Well, this one's going to be kind of weird. I'm trying to think what this would look like if you eliminate the parameter. All right. Well, the big question here is to graph it and to show the orientation. Now, the orientation is not something that I talked about with the last one, but I'll talk about it with this one. So let's put our calculations in first. And I think I promised I would do it here. So second ln e to the negative t, and then you got to hit the right arrow plus t, and then I'll hit the down arrow to come down to the next line and plug in y. This one's going to be e to the t. So again, second ln e to the t minus t. So there's my parametric equation. Really don't know what that one's going to look like, but that's okay. Our calculator will. Let's set up the window. The window this time, I want to go from t was -2. So that's my t min to t max of 2. I keep t step as 0.1. That's probably going to be a reasonable place to keep things. And when I get a chance, I'll try and show you what changing that will do. And we'll graph it. Yay. So we get this, but they asked you for the orientation here. So, let's figure out what the orientation is. And to do that, let me go back to our previous example for just a second and see if I can't help you understand what the orientation is. In our previous example, we started out right here at 2.2 and 3 when when t was equal to 0, and then t equal 1, then t equal 2, and t equal 3. And so the curve is getting traced out in this direction, kind of northeast. If the y-axis was due north, it's getting traced out somewhat northeast. So that's the orientation of this graph. And you show that with a bunch of arrows on your graph. So let's come back then to this example. Okay. So there's your graph. But it's hard to see which way this one got traced out. So I'm going to do something a little cute here. If you press your y equals key and cursor to the left of the equations, you should get a little box like this. And if you press enter, you can change the colors by changing through on this line. But blue is such an awesome color, I wouldn't want to change it. So let me go down here to line. And if you press the right arrow key, you get something like this. Now, it's not enough just to press the right arrow key. After that change, you got to go down and hit the OK button. Now, the nice thing that this will do is it puts this little tracer on your graph. It's a little bit easier to see when that gets traced out. So let's see if we can't watch that as we graph it. So with that change, there you go. And that shows you the orientation. It started out here, it came in towards that point, and then out from there. So, question?
I don't know. It's just that my graph doesn't, like, I don't have two separate kind of lines.
Yeah, I don't either. I don't have the line that's like following the x-axis.
Did you adjust your window so that t was between -2 and 2?
I believe so.
And you're in parametric mode, right?
Oh wait, yeah, I just changed
I
the
got it.
window. Yeah.
Thank you.
Okay, cool. Anyone else having problems with that? All right, so
Wait, what exactly are those two doing? Like the T-min and the T-max?
so that shows you where to graph it. So for instance, let me make a change here. Let me make it from -3 to 3. And we'll see what that does to my graph. And I think what it'll do is it'll fill it out more. But it's still going to come in probably from around here and then swing into a vertex and then out farther. So let's hit the graph key and find out. So there you go. So it greatly increased the size of my graph, but you could see which way it was going. In fact, that's the orientation that I was talking about. And so one of the things that you might be asked to do on an exam is draw a graph and include the orientation. So the orientation you would mark like this. And this graph isn't to scale by any means, but what I want to show you is how I'd like to see the orientation labeled. All right, it's just with some arrows that point along the graph so that you know, we started here and we finished here. Yeah, that's all it's telling you is how that graph is traced out. Because there's different ways you can parameterize a curve, and someone will trace out the curve, same curve, but in a different direction. And so the nice thing about parametric equations is you can really tailor your equations to whatever situation you're looking at. One of the cool applications is a cycloid, and that's the shape. That's a parametric equation of basically a tire, a point on a tire rolling on a surface, and it's just going to be boom and then boom, boom, like that. So nice parametric equation of that motion. And you can see that every now and then the function is not going to have a derivative, but for the most part it will. You can look at a lot of interesting things about that. And I'm sure those of you who are going to work for the automotive industry would have a chance to work with that parametric equation. Okay, are we okay with the orientation there? That's the big thing I wanted you to see as part of this example here, example A. All right, well, let's do another one in which we show the orientation. And this time we're going to do a little bit more. So I'm going to try and keep on adding little things here to help you out. So this one's example B. And again, that's on your sheet. So these are our equations. And let's see. There we go. So those are our equations. I'm going to copy those down. Then put them in our calculator. Do a little bit more. Okay, so let's cut back to this and put those into our graphing calculator. Let's see here. Let me clear these out. Clear, clear. I like to clear this out so that we have a fresh key history that you can look at and refer to if you need to. So back up to here. I had x was t squared minus 1, so t squared minus 1. Then a down arrow, t plus 3. And let's take a look at the window. The settings for t should be -3 to 3, which they are. So I'm in good shape there. Now, unless I want to sit down and think a little bit, it's probably not a bad place to start, is to hit zoom 0. So zoom and then 0. And I'm not surprised to see a parabola in shape. What's different about this parabola? What's a little unusual about it?
It's not a function.
Yeah, it's not a function. Good observation. It's a parabola that opens sideways, and by opening sideways, it doesn't pass the vertical line test. So, well done. Well done. Let's actually figure out the a couple things about this. One of which would be, well, what is the curve without without the parameter t? And the other one is, let's see if we can't figure out the orientation as well. So I'm going to cut back to here and look at the graph. So something like this. And yeah, I'll hold off on that for just a little bit. If it were me trying to figure out, well, what's the equation in x's and y's that represents this parametric equation, I'd probably do this. I'd solve for t from this equation. So I get y minus 3 equals t. And I can plug that into x. X equals y minus 3 squared. Now I hope that when you square out this, you don't give me y squared plus 9. That would be bad. Who can square this out in their head for me? What would that be?
Minus 6x plus 9.
Beautiful.
Minus 6y, right?
Sorry, yeah, y.
It's okay. It's force of habit. I got you. But thank you both. So completing this, it's x equals y squared minus 6y plus 8. All right. And that's going to mean that if you factor this, this would have roots at 2 and 4. All right, that's nice. There we go. All right, so that's part of the problem, is to eliminate the parameter, which we did. Here's your equation. Nice equation that I could save for my college algebra students. But there's one other thing, and that is, what's the orientation? Now, I'm going to take a different approach to showing you the orientation this time than I did last time. Let's take out our graphing calculator and just check one of the settings first. So if you hit the second key, then the window key, make sure your table setup matches this, that you have independent set to ask, dependent set to auto. If it's different than that, change it. Table start and delta table don't matter for our purposes here. But make sure these match. When you get those all set, hit the second key and the graph key, and that takes you to the table. And there's a lot of stuff here that I'm just going to delete. I'm just going to delete all those to get rid of the old stuff. Now our graph started at t equals -3 and went up to t equals 3. I don't know if we need to plug in all those values or not, but we certainly got the room. So let's do that. -3 for t. Oh, and it gives me x's and y's. -2, negative 1, 0, 1, 2, and 3. So it's giving me a bunch of pairs of points, and it starts with the point at 8 and 0. So, okay, 8 and 0 is already on my graph, so that's nice.
What's that point to the left?
So we've got 0, 2, and 0, 4.
Oh, yeah. Okay.
Those are just the X and Y intercepts. So I put those on almost without thinking, just out of a matter of habit. But yeah. Now let's see here. What are the rest of the points? We had 3 and 1. So that's bringing things in a little bit closer. 3 and 1. And then 0 and 2. And finally, negative 1 and 3. Then 0, 4, 3 and 5. And finally, 8 and 6. All right. So 0, 4, let's see, 3 and 5 is what I gotta do next. 3 and 5, 8 and 6.
Are you writing something down?
Yes,
Yeah.
but I needed to write it down with the screen over there, sorry.
Okay.
So yeah, so if you were to take a look at things, this was our first point, this is our second point, this is our third, fourth, fifth, sixth, seventh. But what that's telling you is the direction that this curve was traced out in. So on your exam, what I want to see are some arrows like this, indicating the direction that the curve is oriented in. Now, different parameterization could give you the same equation, but it could have a different orientation to the curve. So orientation is one of the features of a graph that I'd like you to be able to show to me. How are we looking on example B here? Doing okay?
Yeah.
Thank you.
I'm kind of confused. What's the difference between the points in black and the points in red?
Oh, nothing. It's just these points in black. I looked at this equation and just wrote down the points in black just because. But when we did our table, some of these points actually did appear. In fact, all these points did appear in our table if you happen to look back. So it's just a coincidence that some of the points that you would plot in like a geometry class, or not geometry, but a college algebra class, are the points that corresponded to values of t. Your x-intercept, that's when y equals 0. Y equals 0, oh, that's an 8 there. Your y-intercepts, that's when x is 0. So that's y squared minus 6y plus 8. And if you factor that, y minus 4, y minus 2, you should be able to see 2 and 4. 2 and 4 are your y-intercepts. So that's where I got those points from. It's just, just habit. But yeah, they happen to turn into the same points that we would get by plugging in various values for t. And that's good.
Did you also do this on Desmos?
You can. So it's a good question. Let's see here. Do I have that one done on Desmos? Yeah, you can. I'm not as good with parametric equations on Desmos as I am some other things. But for instance, let's just do this. We'll type in t squared minus 1 comma, t plus 3. So that's my x and y coordinates. Now notice it just gave me this little bit here, and I might want some more. So what I'll do is I'll change t minimum to be -3 and t maximum to be +3. And there you go. The only thing that's a bummer about Desmos, oh, maybe you can tell me, what's the one bummer thing about Desmos? Doesn't really show you the orientation of the curve, does it? It just plots the curve. So that's something that's nice about the graphing calculator in this sense, is that it helps you because it shows you the direction of the curve when it's plotted. In fact, let me go back up here and, well, I guess I've got my little style of things still going. So I'll change the window just a little bit. Now here we go. Let's change t-step to be 0.5. Now, what that's going to mean is it's going to be graphing a lot less points because it's going to start out at t equals -3, plot a point for x and y, and put it on the graph. And let's just skip all the way to t equals 0.5 and then do that again. So instead of a nice smooth graph, you see a little bit of kind of this hexagon shape. In fact, let me make this even bigger to try and accentuate that. So now let's graph it. And it's really getting choppy. The nice thing is that it graphs really fast. The bad thing is that it's not as nice and smooth as it could be. So t equals 0.1 or t-step is 0.1 is not a bad happy medium. I mean, if you do something much smaller, like 0.01, let's give that a try, then what it'll do is it slows down the graph because it has to plot a lot more points, but then maybe you get impatient. So there you go. It's plotting an awful lot of points because that's a plot a point every 100th or 0.01 for t. So at this point, it's just like taking a while. And you might get kind of bored. And I don't blame you. So t equals 0.1 is something that I found to be pretty good. I mean, you can always adjust things as needed, but yeah, this is starting to get pretty painful. Okay. But the nice thing is that it just shows you the orientation, right?
Don't worry, Jeff, we have 4 hours.
Yeah. Good one, Nash. Thank you. All right. I hope to be a little bit more informative than watching a calculator play connect the dots, though.
So you have to wait until it fully like plots the graph to even like exit out of it?
No, you can, okay. If you hit the on button, so let me.
Because it's taking forever, and I was like, I don't know how I can back out before it like.
Yeah, so I think if you hit the on button, yeah, because this is like painfully slow. Or maybe hit the clear button, one of the two. There you go. Clear button, get me out of there. And now I can go back and change this to something more sane, like 0.1.
Thank you.
Yeah, I agree with you. I mean, when I first started playing with these things and I realized that, oh, that's too small, my next mission was to figure out, well, how do I stop this? All right, there we go. So that looks pretty good. And it looks pretty smooth. Is it perfect? No. Let's try another one. Example C. So let's see, do I have it? Yeah, I think I got it here. Now, example C is nice because in your WebAssign homework, they actually show you a couple graphs, and they ask you, all right, figure out which one is which. So let's see, make this a little bit bigger. There you go. But in showing you these graphs, they're actually giving you a good idea of what whatchamacallit, a good idea of what your window settings should be. So let's put this into our calculator. So this is example C. X equals t squared. Y equals t to the 9th. And let's take note of the window. It looks like I want to go between -10, or excuse me, 0 and 10 on the x-axis, at least for the first one. And on the y-axis, -20,000 to 20,000. So I'm going to write both of those things down. Have I done enough of these, things on a graphing calculator that you understand this notation? This is my x min, this is x max, y min, and y max. So I'm just kind of writing that down for future reference. All right, now we're going to put this into our calculator and have at it. So let's see. I'll clear this out. There we go. And clear this. Starting all over with a fresh example. So we'll hit y equals. I'll clear out these two. Then I come back and plug them in. So I want t squared for my x and t to the 9th. That's huge. So t raised to the 9th for y. Okay. And I think what they're looking for here is just the graph and the orientation. And we can eliminate a parameter without too much fuss. So for my window, this is where I want to use these settings. 0 to 10, -20,000 to 2,000. Now, if you look back at the handout that I have for you, you realize there was two choices. I chose to get my x min and x max and y min and y max from this one. How come I chose the left one as opposed to the right one? How come I didn't choose something over here? Give you a hint. It boils down to these equations.
Is it because it goes up to positive 10x? So,
Well, it goes to positive 10, but why can't I choose, or why shouldn't I choose a graph that goes to -10 along the x-axis? I can plug in negative values for t, right?
The s number goes up. I think it goes up. The value goes up.
Because it's t squared.
Ah, there you go. Because of t squared, what's the squaring do?
Makes it
Positive.
positive.
Yeah, it's going to make it positive. So all the values that I get for x are always going to be positive. They have to be to the right of the y-axis. All right, you can't get -8 or -6 when you're plugging in values for t and squaring them. So that's why I chose the one on the left.
So if it would have been like t cubed, you could have chose the one. You would have chose the one on the right, or?
Well, t cubed, that would actually probably end up on both sides of the axis, right? It'd be to the left of the y-axis for negative values of t, and to the right of the y-axis for positive values of t.
No.
So, yeah, but your thinking's pretty sound. All right, let's go back here and adjust my window. I want to go from 0 to 10. Actually, you know what? Do I want to go 0 to 10? No, I probably don't need to go that high. 0 to 10, that's t step, or that's my t parameter. I don't think I'll need to go that high, but it's my x min and x max that I need to adjust. X min is going to be 0. X max is going to be 10. Scale of 1 tells you how often there's a tick mark. Now, between 0 and 10, do I want to see 10 tick marks? Maybe not, so I'll put a 2 there. Y man was going to be negative 20,000. And Y max is going to be positive 20,000. Now, Y scale. How often do you want to see a tick mark? If I left it here now, there'd be 400 tick marks, or my graphing calculator would try and cram 400 tick marks from north to south. Probably don't want to leave it there. Let's jump up to 5,000. So every tick mark on the y-axis represents a unit of 5,000. And with these settings, I think I'm ready to roll. So let's just hit the graph key, see what we get. That doesn't look like the picture. Can anyone think what might have gone wrong? This is a good teachable moment. I only got half the graph. If we look back to what we have here, that's only half the graph. How do we get the other half? Well, the mistake was mine, but it's a good one because it's a teachable moment. Let's go back up to the window. The reason I wasn't getting anything below the x-axis is because I didn't plug in any negative values for t. So let's try readjusting this to -5 to 5 and see what happens now. Ah, that did it. So different values of the parameter give us a different portion of the graph, and that's fine. Just got to realize that this is not an equation on x and y. You're not going to get the complete graph usually unless you are really careful about your choices of t, or you just eliminate t from the equation altogether. How's that look?
I'm sorry, what did you do to fix it?
I changed the window. So my original window, I was going t from 0 to 10. I changed it from -5 to be -5 to 5. And so what was going on here, Alex, is that in graphing this, if I only chose positive values for t, I'd only have positive values for y, which is why I was only getting the positive branch. It's only when you choose negative values here that you'd get the negative branch. All right.
Okay.
X is going to be positive always because x is parameterized as t squared. But y can be positive or negative depending on the value for t.
All right, thank you. My name is Matthew, by the way.
Oh, I'm sorry. You sounded like Alex.
That's all good.
All right, appreciate that. So Matthew, did you catch the orientation? Which way should I draw my arrows in all this?
Going up.
All right, so kind of going up. All right, I agree with that. So like this. Yeah, starts out in the lower right, goes up and up. Beautiful. And that's the orientation that they're looking for. You could solve for x versus y. Let's do that. I don't think the problem called for it, but it doesn't hurt to practice. I would say, let's get x, or t by itself, t equals the square root of x, or x to the 1/2. I could plug that in here. I get y equals x to the 1/2 raised to the 9th. Do these exponents multiply or do they add? Which one do they do? Power to power.
Multiply.
multiply, thank you. Y equals x to the 9 halves. Beautiful. All right. I think we nursed a lot out of that one.
With the x-min and x-max are -5, 10 at 5 now, right?
Yes, yes, that's what I changed it to. Now that was just a little bit of a guess, but when I only got half of the graph that I expected, I realized that I had to change my values for t. That wasn't giving me enough. And that probably where I was missing is I didn't have any negative values for t.
So when you're kind of changing the window, right,
Mhm.
for the t, are you basically just kind of like determining how much of the graph is actually showing?
Yeah.
Right.
Yeah. Because now this graph probably extends much beyond what we're seeing. So for instance, if I hit the second key, then, no, actually I don't have to just second key, just hit the trace key. It'll put something on my graph. I'm getting pretty gargantuan numbers here because it's starting out at t equals -5, and I've got something that's close to -2 million. So if I wanted to see the full graph here, I'd have to go all the way down to 2 million. That's below the floor of my basement, so I don't think I want to go there. So we'll just keep the viewing windows like it is. But the unfortunate part is that you can't always rely on zoom fit, because if I did zoom fit here, it's going to really squish my graph. So zoom 0. I'm going to get some crazy, I guess not terribly crazy, but sometimes it does things to your graph that you don't expect. And in particular, when I trace this, I get some huge numbers, right? You can trace t equals 5, for instance. It's going to be on the other side there. But again, you're getting something up to 2 million. Your windows here really tell a story. I mean, look at your Y min and Y max now. The reason you're not seeing anything on the scale on the y-axis is because you have so many tick marks, they just blend in with the background. If I chose, a bigger tick mark, let's say 1 million, then I might be able to see it. So 1 followed by 6 zeros. There we go. Graph. Yeah, and now I can see a couple tick marks on the y-axis, whereas before I couldn't. But it just really squishes things down. You can't see anything on the graph until you get out to, say, x equals 5, 4 or 5. Great questions. I hope that that helps out some.
So on the test, for these questions, is it like you just put like the new equation and then you draw the graph with the t points, or how do you want us to do these kind of questions, I guess?
So that's a good question. What I could ask on the test is draw the graph and show the orientation. I could ask you to eliminate the parameter, all of which we did on the last problem. So, to look back here, here's the graph. In red is the orientation, and here's the equation once we eliminated the parameter. This is the equation in just x and y. So that's all we can get out of it this section. I mean, I hope that you have also picked up some graphing calculator tricks as well, like, the fact that you can do tables. If you wanted to plug in values, you could. There you go for t. Let's see, what else? No,
we don't need like.
Yeah, you don't need like what?
We don't need to draw like a table.
No, I don't think I could ask you to fill in a table. As I stand here, it doesn't jump out at me as a problem that I really want to waste your time on, but I could. I hope you can. It's just a matter of just copying it down, right? But one of the things that's headed your way, not in this section, but in the next section, is some of the calculus for these parametric curves. What do we got going in terms of area, arc length, those kind of things? How about the slope of the tangent line? What's that going to be like? That's a much different calculation here than it was for the rest of this course. The rest of this course, it was pretty straightforward, you know, to find the derivative. But calculating the derivative with parametric equations is going to be a little bit different, actually a lot different. So we'll get to that in section 10.2. For now, we're going to spend some more time getting familiar with the graphs of parametric equations. But here's a good place for a break. So let's take a break here, and I'll see you in a few minutes.